Hello, thank you for watching this video. So in this video, we're doing question 5 of May, June 2025 question paper mathematics paper 1. And the topic is functions, as you can see on the parabola here, right? So let's go. They're saying the graph of f is drawn below. Here's f, is the parabola, as you can see. C is the turning point of f, and B is just another point on f. So you can see you have a parabola here, there's a turning point, then another point. This should be minus 4 here. Not just 4, minus 4. So, at 5.1.1, they are saying, show that f of x is the equation, which is the equation of x, equal to negative 2x squared minus 4x plus 2. So, they want us to show that the equation of this function f of x equal to negative 2x squared minus 4x plus 2. Not sure if you understand this.
Yes.
Are you happy with this?
Yes.
No problem. So how are we going to do this? It's more like they wanted to find the equation of this function. And what you're given the turning point and a point. If you're given a turning point and a point, remember, you should always use y is equal to a into x minus p all squared plus 2, where p and q are the coordinates of the turning point. Right?
Yes.
So your P, Q, these are coordinates of your turning point. You use this one with a minus, of course. So first step you do is substitute P and Q. Your P and Q is C, which is minus 1 and 4. So we have your Y, which is the f of x in this case. F of x is equal to your A into x minus negative 1, because you substitute p, all squared plus a 4, which means the f of x is equal to a to x plus 1 all squared plus a 4. Are you happy with this?
Yes.
The next thing now is just to find the value of a, and then you multiply this out. Find the product of this and the sums. So okay.
You only substituted 4
And 1, 4 and 1.
4 and 1.
Yeah, 4 and minus 1.
Oh, okay.
Because those are the coordinates of P
Okay.
and Q.
Yes, I see.
So now you take that another point that you're given, which is B, which is minus 3 and minus 4. So you do minus 4 there as y,
Yes.
and then this here. So minus 4 equals a into x, which is
X, which is
minus 3 plus 1 all squared plus a 4. Take the 4 to the other side. Minus 8 is equal to, this is your 4a. Divide by 4, divide by 4. Then that your a is equal to minus 2.
Yes.
That case, take the minus 2 and put it back there and then multiply it out. It should give you this. So f of x is equal to minus 2 into x plus 1 all squared plus a 4. So f of x is equal to what? Negative 2 into x squared plus 2x plus 1 plus a 4. Are you happy with this?
Yes.
Then you multiply this bracket out. So f of x is equal to negative 2x squared
Minus 4.
minus 4x minus 2 plus 4. Therefore, your f of x is equal to minus 2x squared minus 4x plus 2, which should be what they asked us to prove. So this
Done.
is equal to that. So we're done with this. Any questions? So they are saying it's 5.2. They are saying determine the values of k for which the function h of x is equal to f of x plus k will have no roots. So we are given a function h of x now to be called f of x plus k. Are you with me? So they want h to have no roots. Are you with me? Are you following me?
Yes.
They're saying h have no roots. They're asking, what should be the value of k? What should the values of k be so that this function have no roots? If you're looking at h of x is equal to f of x. What is f of x? F of x is what we just found.
Minus 2x.
Minus 2 x squared minus 4x plus 2 plus a k. So if I were to ask you, what kind of a function is h of x?
H H of X.
Mhm.
The parabola.
It's a parabola. If you're saying it have no roots, so what does that mean? It means it's a parabola that doesn't have intercepts.
Yes.
Are you with me?
Yes.
It's a parabola with no
With no
intercepts.
roots.
So, a parabola with no intercept, it's negative, this one. It's either it's below the x-axis or above the x-axis. So it never reaches the x-axis. That's what it means to have no roots. This one does have roots. Here's another root, here's another root. But if we were to drag this one down and put the turning point here, will it get to the x-axis?
No.
No. So if we were to pull this one down, let's say we were to pull this one down to this point, it will look like this. Now this one will have no roots.
Yes.
So when they're saying this function have no roots, they're speaking about the function n because it's negative parabola and it has no roots, which means it looks something similar to this one.
Yes.
So in simple terms, you can say they're asking how many times you should pull your f down so that it drops below the x-axis. I'm not sure that makes sense.
Yes.
That's what the question is saying essentially. They're saying how many times should you pull this one down so that it is below the x-axis. So the value of k that you'll get would be the amount of units you should pull this thing down in order to have, no, so that it doesn't have the intercepts. Because you know, it's 4 here. If you drop it 4 units down, it will sit exactly at 0.
Yes.
Right? But if you drop it more than 4 units down, that should be below.
Yes.
That should be okay. So all the values that are less than -4 should be all the values that are less than -4. Because we want to say, okay, look, because this is the turning point, the highest point. Like with the previous question of quadratic, if this highest point drops below, everything else will drop below.
Yes.
Do you remember that 12? That 14, 9, 5, 6, whatever.
Yes.
So if that 14 had dropped below, then everything else does. So in this case, if this 4 drops below this 0 line, then this function will look like this. So it's more like how many units down should we drag this?
More than 4.
Or maybe less than 4.
Okay.
Or more than 4 units down. If we're adding, we should be adding something that is less than -4.
Yes.
You're right. So in this case, we should, okay, we have a 4 there, right? So it should be 4 plus some k should be less than 0. So your k should be less than -4, which means you should drag that thing less than 4. You should drag that thing more than 4 units down, or you must add less than 4 units here so that it becomes negative. Or this is the quickest way you can do it. A more logical way, not logical, but more precise way to do it. You can say, we want this to have no roots, right? So we want it to have no x-intercepts. So let's equate it to 0, knowing that we don't want this to have intercepts. So this is another option. So we can leave here, there it is correct. But another way we can do, we can say, okay, we want this to have no x-intercepts. We equate it to 0, knowing that it will not have intercepts. So in that case, say, okay, our h of x equals 0, right? Which is equal to -2x squared minus 4x plus 2 plus k. Are you happy with this? Oh, plus 2 plus k. Are you happy with this?
Yes.
So if this does not have roots, if this does not have solutions, what does it say about the discriminant? This discriminant is less than 0. And you know your discriminant is b squared minus 4ac, which is less than 0. Discriminant is this.
Yes.
So if it doesn't have real solution, the discriminant is less than 0. So we'll say, okay, our discriminant is 4 all squared minus 4a into c, 2 plus k. This is less than 0. That's all for k. Should come out the same as that. So we have 16 plus 8 into 2k, 2 plus k, less than 0. Because this is 8.
Yes.
So the answer to this will multiply here. So 16 plus 16 plus 8k less than 0. 32 plus 8k less than 0. 32 8k divided by 8 divided by 8. So k, oh or should be negative? Less than? What is the answer?
Minus 32.
Huh?
It's minus 32.
Divided by 8.
It's minus 4.
It's minus 4. Because look, take the 32 to this side, become negative. You're left with 8k.
Yes.
Divided by 8. So you could have done it that way or this way.
That's why.
Nature of rods.
Yes.
But even this one, you wish you know, if you drag this more than 4 units down, it should work. So we're done with 5.2. Now we're going to move to 5.3. Looks like we might need a bit of space. So let's clean the board and we do 5.3. So let's clean the board and do 5.3. Okay, so now we're doing 5.3. 5.3 reads as follows. They're saying the graph of y is equal to g prime at x, where g is a derivative of g, is obtained when f is reflected over the line y is equal to 4. They're saying draw a sketch of a graph of g if g at 0 is less than 0. Clearly indicate any stationary points on your graph. Are you with me? They're saying now, let me repeat this thing again. The graph of y equal to g prime at x, where g prime is a derivative of g, is obtained when f is reflected over the line y is equal to 4. Draw a sketch of g if g at 0 is less than 0. Clearly indicate any stationary points. Fine. So, they're saying now, we have a graph, right? Let me use a different color, just so that we try to understand what they're saying. So, I'll use green. So, we have a graph y, which is called g prime and x. Are you with me? So, how do you get g prime? To get g prime, you have to derive your g with respect to x. So, you must derive your function g with respect to x. So, the function y or g prime is a derivative of some original function with respect to x. Do you understand that? Which means to get your g prime, you have its originality is a derivative of g, always coming from. Are you following me?
Yes.
How do you get this g? They're saying to get this g, which is the derivative of the original g, actually, to get this g prime, which is the derivative of g, we must reflect our f about the line y is equal to x.
Yes.
Line y is equal to x. So,
Y is equal to 4.
is y is equal to 4. So, this you are reflecting your f about this line y is equal to 4.
Yes.
To get what? To get g prime,
Yes.
which is a derivative of some g. Does that make sense?
Yes.
So, in that case, your y is equal to 5. What kind of a line is this one? Orientation of it.
Oh,
It's a horizontal line. So, your horizontal line, this is y is 4 here, right? So, it's 4 here as well. So, you must reflect about this line y is equal to 4, this line over here. You are reflecting this function over here. So, what you will get is the image of f, right?
Yes.
Which is defined as a derivative of function g.
Yes.
So, if you look at it, this is how it will look like, more or less. So, this is the image of f, which is called g prime. Not sure if this makes sense.
Yes.
So, in my opinion, look, the function of this function f, it has the y-intercept 2, right?
Yes.
So, which means what we have here is what? Is 2, and here is 4. So, the distance between these is 2 units, right?
Yes.
So, that distance is also 2. So, this should be 6 up here. Do you understand?
Yes.
So, this is g prime. And g prime tells you the gradient. Right? And we called it, I called it a gradient function. It tells you the gradient. And if you look at your g prime is always positive.
Yes.
So if your gradient is positive, what does it say about the function? The function is increasing. Even here, the turning point is still positive. So the which means this function is always increasing. So if it's always increasing, it doesn't have turning points. It doesn't have maximums and minimums. Because if you talk about the maximum, because if you look at it, this gradient function is positive, right?
Yes.
It has the positive shape of a parabola. So which means your original cubic was also starting by increasing. So it's always increasing.
Yes.
Are you following that?
Yes.
So if I draw this, let's say I were to draw this, you can say that this cubic, because they want you to draw your G, which is the original. They want you to draw the original cubic that is represented by this one.
Yes.
So if you're looking at this, it has the maximum and the minimum. So it increases here, decreases here, increases there again. But this gradient function is always increasing. Right?
Yes.
So which means if we have the turning point, the minimum and the maximum, this doesn't match. Because if your gradient is positive the whole time, which the function is always increasing, the closest thing that I would accept something like this maybe. So where you have a point of inflection, a horizontal point of inflection. I'm not saying it's correct, but that would be the closest. Let's say you have something like this. And let's say this is a point of inflection, right? And your tangents here are horizontal. So if your tangent is horizontal at the point of inflection, which means the gradient is 0. Because if you have a horizontal tangent, because think about it, when you find these points, you derive and equate to 0.
Yes.
The reason you're equating to 0 is because then the turning point, the tangent that you can draw are horizontal tangents.
Yes.
So it's more like you find the x values where your tangents are horizontal. Are you happy with that?
Yes.
So in this case, if you have a horizontal inflection like this, that would mean there was a point where the gradient was 0. Do you see a point where the gradient is 0 here? No, because this thing is always positive. You always have a positive gradient. So your point of inflection can be that. So these are stationary points, and that will be a stationary point if you think about it, because the gradient is 0. So if it's always increasing, I don't think there is a stationary point. I'm surprised that they're saying clearly indicate any stationary point. So I would think it would be something along the lines of something like this. This is the closest thing that I would think should be that. Because it's always increasing. But you can see here it's increasing at a decreasing rate because the gradient is getting shallower and shallower. And then it becomes steeper and steeper. Because look here, it's increasing because this gradient is always positive.
Yes.
So it's increasing at a decreasing rate because the gradient is getting smaller.
Yes.
It goes to the lowest. And then it increased again. So I'm not sure if I would call that a stationary point. Because it's not stationary. It just changed the rate of increasingness. That's what I would think. So if I were to plot it, I would plot it like this. So I'll say, let's just have this line here. This is the point where the inflection occurs, right? This is the point of inflection. So they said to us, G at 0 is less than 0, which means it should pass below this line, right? So I'll draw that graph. Not sure which color would work well. If I use green, oh no, green is there. Let's use red. I'll put it maybe somewhere here, the point of inflection. So I'll draw something like this. Because it's always increasing, right? Yeah. Even here, it's not horizontal, still going up, but it changed from increasing at a decreasing rate to increasing at an increasing rate. That's how I'll draw it. So I'm not sure if I was saying this is a stationary point, because how is it stationary if the gradient is always greater than 0? So it just, in my opinion, it just changed from increasing at a decreasing rate to increasing at an increasing rate. So as you can see over that. So that's how I thought of it. I'm not sure if it does make sense. But let's post it and hear what they have to say. So we're done with question 5, and I hope it does make sense to you as it does to us. So I'm going to move on to question 6. So for now, let's pause the video and prepare question 6.